Good morning all. Here we are on a nice rainy day. This is a temperature controller. It's manufactured by PMA, small number KS94. Down here is the COM port. It's RJ11 COM port. So I have RJ11 cable going to my circuit over there. And the data from this temperature controller is RS232 format, but it's not plus or minus 10 or plus or minus 8 as you would normally see. It is 0 to 5. So I had to make a circuit that would convert the 0 to 5 volts data from the temperature controller to RS232 plus or minus 10 volts for the laptop program. Let's go ahead and plug in our cable. Get in there. There we go. Now my circuit uses an RS232 IC, and its part number is ADM233LJN, manufactured by Analog Devices. There's also the Max 232, same IC, same function, identical. Now we'll take a look at some of the waveforms on this as we get into the work here. But let's go ahead and power everybody up. I have a 7805 3-terminal regulator right here that takes 8 volts from that power supply and regulates it to 5 volts DC for the 233 IC. Now we've got our temperature controller powered up, and you can see it says fail. That's because I don't have the thermocouple attached to the back side of that unit right there. Let's go ahead and power up our program. Go to PMA Tools, and I'm going to click on ET-KS94. Oh, there we go. There we go. We're up. Okay. Now, this is what you see when you first bring the program up. We're going to go over here to File, and we're going to pull in the parameters from the temperature controller into the laptop. It says Project PC, an arrow pointing toward PC from the controller. I get confused sometimes. Sometimes I'm afraid to overwrite things in these units right here. If I get from laptop to unit or unit to laptop mixed up. They need to be clear, a little bit clearer on their menu items right here. I've seen some, I'm going to get sidetracked, but I've seen some that say upload and download, and that's it. Well, am I uploading from the unit to the laptop, or am I downloading from the unit to the laptop? That's a scary proposition right there, because let's say I accidentally downloaded something into the unit before I was able to save what was in that unit to the laptop. That's aggravating. So here we go. And it says the project is, the engineering tool will be overwritten. Continue? Yes. Click on yes. You see a little bar graph down here. That indicates us that data is leaving the unit, going through the 232 IC, being converted to RS232 voltages and sent to the laptop. Here we're in now. Let's go over here and we'll look at the parameters. Here's some of the parameters right here. It says W0 is -99.9, W100 is 950.0. There's tabs and things like that you can go through and look at. But let's go close to that oscilloscope right there while I'm probing these connectors right here. And and you'll get to see what RS232 looks like from the controller and from and to the laptop. Okay, let's fire up our oscilloscope here. Okay, now I'm going to do a file transfer from the unit to the laptop, and we're going to look at the output of the temperature controller. Here we go. You can see it's right now set at 5 volts steady. Now, there's data from the temperature controller into our converter. There we go. That's full transfer. Now let's see what comes from the laptop to go back into the temperature controller while we're doing that data transfer. Okay, again, that pin is at 5 volts. Here we go. This is from the laptop being converted from plus or minus 10 volt data to 0 to 5 volt data and going back into the temperature controller. There we have a transfer. Now let's go and look, see what the data looks like on the transmit receive side of the laptop. Let's see, we'll go to, this is the transmit pin of the laptop. You can see we start out at negative, that's almost probably negative 8 volts. We're going to do a transfer again. Alright, there's our data from the laptop into our converter and being transmitted into the temperature controller. Now let's look at the receive side of our laptop. Alright, this is the receive pin on the laptop side. There we had plus or minus, what, about 8 volts right there, plus or minus. That would be plus or minus 16. Yeah, plus 8, minus 8. Okay, now we're going to look at some of the pins on that ADM233 IC. Pull out the data sheet here. Now at the end of the video, I'll show you how I figured out that RJ connector, its pin outs, who was input and who was output and who was ground, and I'll show you the drawings of my circuit over there, the RS232 converter that I put together. Let's look at some of the waveforms on the ADM233. Here's pin 1. Okay, pin 1 is T2N. That's a TTL input. Here's pin 2. That's T1N. Oh, get on it. There's T1N. That's a TTL input. Here's pin 3. That's R1 out. That's a TTL output. Here's pin 4. Pin 4 is R1 in. That's a RS232 input. Here's pin 5. That's T1 out. That's a RS232 output. Pin 6 is ground. Pin 7 That's VCC. There's our 5 volts from the 7805 3-terminal regulator. Pin 8, that's C1 plus. Pin 9 is also ground. Pin 10 is C2 minus. C stands for capacitor. Here's pin 11. That's C2 plus. Pin 12, that's V minus. 13, C1 minus. 14, that's V plus. 15, C2 plus. 16, C2 minus. 17, V minus. 12 and 17 are tied together. 18, that is T2 out. That is RS232 output. 19, that's R2 in. That's RS232 input. And 20, that's R2 out. That's a TTL output. There's all the pins on that IC. Here's a picture of what we just looked at right there. Hello, here we are at the house, and we're going to talk about the COM port on that temperature controller. Now, if we were to look into the RJ11 connector, this would be the leftmost pin, then the second one, third one, and fourth pin. Now when I map out a circuit and try and figure out how to work it, I'm only worried about the inputs, the outputs, the ground, and maybe a voltage. So here we take this first pin, the leftmost pin on that RJ11 connector. We have a voltage divider circuit right here. It runs into an AND gate, and then it runs into an OR gate. The output of the AND gate runs into an OR gate, and then we hit the receive data pin on this microcontroller. The microcontroller part number P80C32UFAR. Pin 11, receive data. So I knew that this was the transmit pin into that RJ11 COM port. Now, the second pin, we have another OR gate on that goes to the second pin. Now let's follow B back. It gets a little bit convoluted with the way they did this. I don't understand it, because with me it would have been straight into the receive data and straight out of the transmit data, but they had to do all this other stuff for some reason. Beyond me. I wouldn't have done it this way. So let's go to B. Here is B, it comes down and it goes to the transmit data pin. But it also goes over here to something that's not connected. Huh. Strange how they did that. So the P80C30 UF AA? Is that AA? Yeah, AA. Did I say AR? I did, sorry. The transmit pin on pin 13. So we knew this was receive data and this was transmit data. Now this third RJ11 pin went to ground. And at the time when I made my circuit, I didn't know I could take 5 volts from the temperature controller to power up my circuit. So I had a separate 7805 to power up that ADM233 RS232 IC, but I could have took it from this fourth RJ11 pin right here. Something to think about in the future if I ever make another board. Alright, so transmit data to this OR gate, receive data through this circuit right here. Let's go look at my circuit. Here we are at the house. We've got to hurry up, it's starting to get dark outside. Now this is my circuit to convert the 0 to 5 volts from the temperature controller to plus and minus 8 volts to the laptop. Now up here, pin 4 of the RJ11 connector, the temperature controller puts out 5 volts, and at the time I didn't realize that, and so I power up the ADM233 on pin 7, 6 and 9 ground, 7 VCC with the 78S05 CV. We apply about 8 volts right here to pin 1. It's ground, pin 2 to pin 2 right here. So 8 volts in ground, and on the output of the 78 S05 CV we apply 5 volts to pin 7 and ground pin 6 and 9. Now in the future, if I ever do this again, probably not, but if I ever do, I'm going to take 5 volts from the temperature controller to power up this RS232 IC. Here on pin 2 of the RJ11 connector, and I had orange wire current to that. That's transmit from the temperature controller into pin 2 of the ADM233, and its output, so we have 0 to 5 volts on pin 2, and on the output side we have pin 5 is 0 to 8 volts RS232 data. That goes to pin 2 on the DB9F connector, the receive pin on the laptop. On pin 1 of the RJ11 connector, that's receive data into the temperature controller. And so when the laptop transmits RS232 data of plus or minus 8 volts in our case that we saw with the oscilloscope to pin 19, pin 20 is connected to pin 1 of the RJ11 connector, the receive data pin on the temperature controller. So transmit data of the temperature controller goes to receive data of the laptop. Receive data of the temperature controller comes from transmit data of the laptop. Now down here pin 3 of the RJ11 connector was the ground. Now, I used terminal connections P3 and P2 so that I could adapt this circuit to other applications other than DV9F or RJ11. I could connect different connectors to this ADM233. Now let's take a look down here. So sorry, a friend of mine calling to make sure that I made it through the storm. Very good friend of mine. And always try to keep up with your friends and families, make sure they're okay. So here on pin 8 and 13 we have C1 plus and C1 minus. According to the data sheet, they are no connection. You make no connection to these points right here. Now, pin 12 and pin 17, you jump together. That's V minus and V minus. Down here, it's called internal plus 10 volts power supply. Pin 14, that's V plus. And I don't make no connection to that. Over here on pins 10 and 16, again we jump those together. That's C2 minus, C2 minus on 10 and 16. Here on 11 and 15, that's C2 plus and C2 plus. We jump those together. Now these are our charge pump connections. They are the connections to create that plus and minus 10 volts DC, and which in our case was plus or minus about 8 volts DC. There you go. 0 to 5 volts data over here, plus and minus 8 volts data over here. Thank you very much for stopping by and see what we're doing next. Take care of your friends, take care of your family. We'll see you in the next one.